Okay, for project 6-11, we have several threads. Both of these can be revolves. We'll look at the center line and cut in half, so we basically draw this profile. Previously, we had issues with the stack up here, so we'll have to double check that. The threads are M20, so we'll see what's available in the cosmetic thread or as the thread feature, and then we'll deal with the chamfers. We can go to create that geometry, and the chamfer over the hex is always there's a couple of strategies there. So we'll look at both of those, and then for the threads, we'll also do the cosmetic thread, the feature thread, and a swept cut thread. The hex screws are going to be from the assembly toolbox or the library of hardware. So let's fly this out of the way. Oh, I don't think it went. There we go. And we'll start with the screw. So I already have a part open. Now it is in inch, pounds, and seconds, so I'm going to switch over to millimeters, grams, and seconds. We'll start on the front plane. And I'm going to stay with the S key here, so if you prefer right mouse button and sketch entities or still have the command manager, about time to start experimenting with some of these other options. So S key and center line, vertical, infinite length. I'm going to place that on the origin. Again, the advantage of our infinite length center line is we won't run out, we won't draw over top of it. There will always be something there. So this is going to give me a radial, which I'm not sure what I want, but if it's the M20, I can put that in as 10. And the choice here is, do we include the chamfer in the sketch, 3x45? And these dimensions are going to get a little complicated, so I'm not going to worry about putting them in. And we have the 2 slots. And then we'll pick up for the hex head. Now the issue with the hex head is going to be, well, it's not round, so if I include it in the model geometry for the revolve, and once I close it off, it goes to that shaded area, so it's part of the region. If I include it, then nope, I missed that. Let's go back and I'll right click. I wanted construction geometry. All right, so if I include it in the revolve, I need it for reference, but if I include it in the revolve, then I'm going to have to do something different with the cut. I'd like to just put the polygon on top and be done with it, but then let's see, if we go with the 25 millimeters across the flats, and because those are both construction lines, it's not going to like that. So let's try a point, and I can go to the point and end up with the 25 millimeter across the flat. Oh, and since I included the chamfer, I actually need to get rid of that one now, and that'll help out. Let's go ahead and apply this as if it was radial. And let's see, we're at the 10 millimeters there. And let's see if we get out of that. No, I need to actually be in the select. So if I pick on the dimension, and I'm not getting those diametric. Oh, so this one is make diametric, so I'm not sure where I was getting those. So, all right, so this one Did not pick a vertical. So the chamfer, so something got coincident or vertical. So let's see if we can diagnose this out, otherwise I'm going to have to move. Oh, there it goes. I had the bottom one, couldn't see the blue dot. Alright, so we just kind of keep clicking on things until we find which one moves. Alright, so 3x45 is the same type of definition that we would get if we were applying the chamfer or sketch chamfer or feature chamfer. And I want those two to be collinear. Actually, I need all three of those to be collinear. And then the slot is, now we're going to go with the definition. So to the bottom of the slot is 23. And then from the top down, and one of the reasons that we needed the hex is the way they dimension this. So we can do for accuracy, when we make our drawing, we'll clean that up a little bit. Okay, so from the top to the top of the slot is 25. So that gives us our locations. And then 5 millimeters for the two grooves. And since it grabbed the 90, we'll hit escape once. And then I can make those collinear as well as equal. And that'll give it the position. And once I pick one of those to add to the dimension, the other one will follow. So if I just come out here to the object line, notice it's highlighting in orange. That's not going to give me the diametral dimension. It's only going to give me radial. So I want to be at 15 millimeters with the diametral dimension. And then let's see what's not able, oh, the overall height. So we have an overall height of 73. So just by grabbing that and moving it, that gives me an indication of what's missing and will cause the sketch to go fully defined. Alright, so I think everything's in there. And we have the 25 millimeters across the flat. So if I were looking to put the, let's see, they call it, I don't see the call out for the chamfer across the top. 3x45 would be pretty big, but it'll pretty much be on the outside. So let's go ahead and just put something in for reference. And no, I did not want the midpoint. So 45 degrees, and maybe that will be 2 millimeters instead of the 3. All right, so if I go ahead and revolve that, it's going to pick that geometry up. I could pick it as a region and leave it. Why don't we do that? Let's go ahead and pick it as a region, because then I can come back and share the sketch and possibly use that as a cut. So having it two separate features is fine. And because I'm 25 across the flat, I would need this to be to the outside. When we look at this from the revolve, and I get the hex in place, then I would maybe go to the right plane, could draw that same geometry interior to the polygon, and be able to complete the chamfer cut. So if I revolve, it says they're both enclosed, it's fine, but I really just want that one. So there are multiple center lines, construction lines, so I need to tell it which one, and we're going 360 degrees, so that's fine. I can now go open up the sketch. We'll go back into the polygon, and if I drag that out, now if I want to use our previous sketch, then I'm going to need to show it, and I can make that coincident with the flat, and one of these will need to be vertical. All right, so some combination of the center point and a vertex to be vertical, or one of the object lines in the sketch to be vertical. All right, and then this is one of those places I could give it the 5 millimeters, but if I'm driving off of that sketch, then we can go into the features, extrude boss base, and this will be an up to vertex. And the vertex is where edges come together or point is generated, and we have that shape. All right, so now you can see it's kind of to the outside of the flat. And if we go back into that sketch and features, this time it will be a revolved cut, the axis of revolution, and then we need to pick our geometry, which is the interior of that triangle. So when it cuts around the outside, it generates that chamfer. All right, the other option then is, nope, didn't want to hide it. I wanted to suppress that feature. So show, suppress the cut revolve. We'll hide sketch 1. And we'll look at doing this on the right plane. And so maybe the advantage of doing this on the right plane is that we are interior to the part. There is a little more visual result there. So 2 inches or 2 millimeters, 45 degrees, and we could adjust that accordingly. So let's see. We can also, I think I put that on the sketch. So let's see, if we're 25, if we drew that that circle, let's make that a derived. And I want it to, or a driven, there it was. All right, so maybe I want to make that a driven part. And we'll go back to, all right, 3. S key center line, didn't do that first, so infinite length vertical. Place it on the origin. Okay, so if we were to go into our dimension and set this to 25, then our value is just a little under 2 millimeters. Is that going to matter? Well, we'll have to compare and see what the result is. So we're going to go ahead with the revolve cut. Now that one you see comes up just about perfectly tangent. All right, so there is the solution 2. If I suppress that one out and unsuppress that one, so yeah, it's always going to bark, and even though it's suppressed. All right, so that point, whole lot of nothing of of a millimeter is 0.07, which is what, in the couple of tenths of a thousandth range, is not showing anything crazy different. So just be aware that under different circumstances you have those options. All right, onto the threads. All right, so first is cosmetic thread, and we're going to do these as configurations. So the cosmetic thread is an annotation, insert annotation. If I was doing a lot of these, I would customize the heads up and add this tool. We'll set this. We're starting from the edge. It's a machine thread. It's showing me M20 by 2.5 as the coarse. I will go with the M20 by 2, and the depth will be up to next. So it should find this this edge, and we could probably go with the 2.5, and it wouldn't interfere. So that gives us our cosmetic thread as the default. And then we'll go in, create a configuration. Whenever we're creating configurations, make sure to add configuration. This one is going to be the thread feature. And if I pick that leading edge, and then go to the features, whole wizard down to thread, it's going to give me the standard warning. When I get tired of seeing that, I will say don't show again. The thread location doesn't seem to like the pre-select. And optional starting location, we'll have it start off of the part. And with the chamfer, we can go ahead and build that in. And then up to selection, in this case I can go a little bit past. And it found the M12, and it is not a tap, it is a die. All right, so metric die. Die is to the outside and the tap is the inside. So M20 by 2. And it will be a cut thread. Since it's manufactured this way, this is the process that makes the most sense to me. All right, so it cut a little bit into the next one, so we'll want to look at that feature and offset it by just a little bit on the face. So 1 millimeter, reverse the direction. All right, and that makes a full cut thread. So if I go back to the default and then create a configuration, a swept cut thread. And we'll make this optional because there's a few steps in here, and the first time you see it, this is going to be a try it, but don't spend a whole lot of time to make this work. So first thing we need is a curve, and the curve requires a base circle. So our base circle, we open up a sketch on the end, will be about as easy as anything. And S key and convert. And if you haven't added the convert to the S key, just keep in mind that it is available under the sketch. And all we need is that circle. And then under the features, we're going to go to curves. And inserting the curve, we want a helical spiral. We're going to reverse the direction. It has a pitch of 2 millimeters. And the number of revolutions, actually we should just give it a height. So I want to do pitch and revolution, or height and revolution, or height and pitch. Spiral is like looking at a record, and if you don't remember vinyl, then it's kind of like looking at a CD with all the swirls, but not really. Basically, it is, as it says, just a spiral. Our height for that that was 23 from the base, but that's also going to drive where I start or finish. So I'm going to give it a little bit more to the center, make sure that it goes completely off, and then we'll be able to start our geometry. All right, so I didn't really check where that endpoint was. So it should be on the front plane. That's going to be important because as we draw our triangle, S key line, we're going to create a 1.99. All right, and the 1.99 is important because one of the rules of the swept cut is that it cannot intersect itself. And there's a lot of geometry there to be tangent to, apparently. So let's go ahead and put that in. We'll make it for construction and horizontal. And as a 60-degree sharp V thread, put in the geometry, and then this endpoint of the construction line can be pierce. So what pierce says is there are two possible solutions. Where this sketch lies in this plane, it can pierce the curve here or here, times however many we go up. Now the previous versions, the sketch would not go both ways, so you kind of had to make sure it was at one end. I think there is a setting now for it to go both ways, so you could pretty much pick one of those and still have it be available to terminate. All right, so the helix and the sketch, we're going to go to features and make this a swept cut. And again, I do this more because this is how I visualize making the parts. So let's see, align within faces, minimum twist. Don't really have to worry about those. Follow the path. We see the preview. And then this is a little sharper. It does not have the root radius or the crest radius. This is a completely sharp V thread. And then after we're done, we'll hide the helix. All right, so that gives us the hex screw. Oh, I guess we need to do our document control now. So new folder, assignment 5. And this can just be the hex screw. All right, going to the next, we'll do a new part metric. All right, and then the body, we have the choice of trying to put all of this geometry in at one time. Let's fly this back in here. So we can do all of this geometry at one time, or I can create the cylinder and then do the revolve at the interior. So when in doubt, make it simpler, cleaner, not more difficult. So what I just did, and this would be a good place to take a look at changing sketch planes, is I drew this in the front plane, but I really kind of wanted it to be in the top plane. So we're going to take a look at what that entails. So we had a diameter of 36, and I'm going to go ahead and extrude this so we can look at the results. Sometimes they can get a little strange. It's a blind in condition to 100 millimeters. And so I see it make the extrude, I go to the isometric, and I think, wow, this would be great to put into the assembly in a vertical orientation. So I can right click on the sketch, go to the sketch plane, and instead of the front plane, we're going to go pick the top plane. All right, so as long as you catch the geometry soon enough, you have a kind of a 50-50 shot. It may point down, which in this case we would just edit it and reverse the direction. And go ahead and leave that. It doesn't matter which way we're going to generate the, we're going to be generating this geometry interior to the part. So again, sketch on the front plane. And as we go in and start our geometry, infinite length vertical. Oh, I picked a regular line, so that's for construction. Make sure that that went fully defined. And then the line. And we come down some distance. And then we're going to move in and pick up to the base. And it's a little difficult to see, so going with hidden lines visible and a little bit of a step, and then the 118-degree drill point. Looks like 118 anyway. All right, so we need to close this off so that it is something that is a region that can cut. And apparently I missed that one, so let's try that again. All right, so we'll go through and start putting in our dimensions. Make sure your picking the center line, so we have the diameter of 22. Gives us the clearance. To the hole centers then are 21.5 and 24. So we'll go from the top. I don't want to do that math in my head, so 21.5 plus, make sure I'm typing it in right, 24 should give us the 45.5 to the step. And then the overall here is 28. And then we have 4 millimeters for, hold up. And then for the drill point, whatever, oh, I guess really didn't get that diameter. And the M20, you know, I look at that and I think I would just, I wouldn't put that step in there unless there was some other geometry that we're missing. I really wouldn't put that step in there. I would just take the tap drill and run it all the way to depth. So I don't see anything called out. And maybe if we do the 20 minus the 3 millimeters times 2, that would give us 14. All right, so just a number to start. Anytime I have a missing dimension or a guess dimension, maybe that becomes for inspection. And then if I want, same with the angles as the linear dimensions, if I just want a half angle, no, I may be getting that confused. Now we'll try it. No, pulling it all the way around to the adjacent. So 118 degrees divided by 2 would be 59. And I need to drag that one out a little ways. I was hoping that when I picked the center line, it would just give me the full adjacent angle, not the wraparound. So with our metric, M20 by 2, take the 20, subtract 2 from it. It gives you 18 millimeters as the minor diameter of the M20 thread. All right, so we're going to go into the features, perform a revolved cut, and the axis should not be, unless I missed something, or I have a gap somewhere. Well, we'll see what it does. All right, well, we got the geometry in there, so that's pretty much the main thing. All right, so I've been telling you most all this semester, been telling everybody for a long time, stay away from the 3D sketches until you actually need one. All right, so we're going to do the threaded hole, the M6 by 1. We'll do that in 2 ways. So if I take the right plane and hold down the control button and click on that plane and drag, I will get a reference plane. All right, and it's going to be parallel, and my second reference will be tangent to the cylinder. That makes it nice and convenient for the hole wizard to pick up that geometry. Alternately, we could have gone features, reference plane, or reference geometry plane, and when I pick that plane and hit the S key, or we go into the hole wizard without picking it, when we go to positions, then we're still going to ignore that 3D sketch on this one, but put it into that plane. All right, so threaded hole, ANSI metric, bottoming tap is fine. M6 by 1. And don't want it to do through because it will go through both walls, so just up to next. It is call out. probably don't need the thread class, countersinks, all of that. So we'll just go into position, and on this side, I guess it didn't keep that. So whenever I see that 3D sketch, I'm going to go grab the plane again just to make sure. And we'll select, control select, go vertical. And then in our dimension, bring this down to the 21.5 and accept it. Alright, so we can check that by going back to the front plane, doing the hidden lines removed, hidden lines visible. And if I go back in and hide that plane, then that just kind of cleans up. Alright, so alternately, we do the same thing. S key, whole wizard, M6 by 1, everything looks good. And this is the case where I tell it I want a 3D sketch. The advantage of the 3D sketch is I can put this anywhere. The disadvantage is I got to figure out how to get it related to something. So that being the challenge, we'll go ahead and place it close to where it's supposed to be. And we'll look at this from the right side. And this can be a long Y, so kind of making it vertical. Didn't like that. All right, because it's pretty much tied. It's trying to make it vertical to that point. So why don't we go with a center line for construction, and I'll make that vertical. The end point of that can be along X and position it, and then instead of dimensioning between the points, I'll just grab the center line and make it the 41.5. So kind of a different set of rules, different set of choices that get made with the 3D sketch. And then the difference you're going to see is sketch 5, sketch 4, 3D sketch 1, sketch 6. Alright, so I think that's our geometry and we're ready to assemble. Make sure to save this. So this can be the base, pretty much whatever you want to call it. And we'll go through the assembly and the toolbox and drawings next.